Hi everyone, in this screencast, I'm going to be talking about shielding. So first thing first, what is shielding? Well, shielding occurs when electrons are repelled by other electrons between them and the nucleus. And when that happens, those electrons feel the force of the nucleus less. The more energy levels an atom has, the more shielding takes place. And electrons can only be shielded by other electrons in energy levels between them and the nucleus. So for example, an electron in energy level 4 could only be shielded by electrons in levels 1, 2, and 3. So what does shielding look like? Well, this diagram gives us an image of what shielding looks like. Remember, electrons are negatively charged, and they're attracted to the positively charged nucleus, and that's shown by this blue arrow. So this is showing the force of attraction between this electron and the nucleus. But because of shielding, this outer electron is actually repelled by other core electrons. So there are 3 core electrons shown here, which are all repelling my 2 outer electrons, which are shown. And that means that these outer electrons feel the force of the nucleus less and are pushed a little bit away from the nucleus. So how does shielding change as we move down a group on a periodic table? And remember, our columns are called groups. Well, for group 1, for example, we have the elements lithium, sodium, and potassium. And you can see that each one has more shielding electrons than the one before it. Lithium only has 2 shielding electrons, whereas sodium has 10 shielding electrons, and potassium has 18. So as we move down a group, the number of shielding electrons increases, and my outer electrons are shielded more as I move down a group. And that's true no matter which group we look at. If we look at this group with beryllium, magnesium, and calcium, again, the number of shielding electrons increases as we move down this group. And we get that number, again, from the number of inner electrons, which are shown here in green. What happens if we look at the shielding trend across a row or a period? Well, if we compare lithium, beryllium, and boron, each has 2 shielding electrons. So the amount of shielding is not changing as we move from lithium to beryllium to boron. However, if we compare sodium, magnesium, and aluminum, well, now they each have 10 shielding electrons because we've added an energy level, but still the shielding is not changing as we move across a group. Same thing if we move down to period 3. The shielding does not change as we move across this period from left to right. They each have 18 shielding electrons. So how does shielding relate to Coulomb's law? Well, remember that Coulomb's law tells us the relationship between the force of attraction and the charges and the distance between those charges. And if shielding increases the distance between electrons and the nucleus, because those electrons are pushed away from the nucleus by other electrons a little bit, well, that means that shielding is going to cause this number to go up a little bit. And when that happens, our force of attraction will go down, because the relationship between distance and force of attraction, according to Coulomb's law, is inverse. So again, shielding, the more shielding you have, the greater the distance those outer electrons are from the nucleus, and therefore the lower the force of attraction between the nucleus and those outer electrons.